Hello, and welcome to our next lesson in our Data Structures and Algorithms course. We are in Unit 2, and we are studying the stack. So I want to talk about an abstract data structure today called a stack. A stack is also sometimes referred to as a LIFO because it is last in, first out. It's an abstract data structure, which means we can implement it in many ways, and it's a good exercise too. But today we're going to use our doubly linked list. So here's the stack interface. It's generally agreed upon that the stack interface has three methods: push, pop, and peek. Push pushes an element onto the top of the stack. Pop removes the element at the top of the stack, and peek returns the top element on the stack. We call it a stack, and it's like a stack of playing cards, which I've shown here. Every time I add a new element to it, I'm adding to the top of it. And so whenever I remove an element, that's what's going to come off of it first, that element that I just put on there. So that's how it works. You keep adding the top. The very first thing you put on, if you keep adding stuff, that'll be the last thing you take off. So how are we going to make this interface? I don't know if you've made an interface in BlueJ in a while, so let's make one together. We're just going to go new class. You can actually pre-select interface if you want their pre-made code, but that's okay. We'll just erase it all anyway. Now, there could be some name collisions here. Java.util.stack is a deprecated class that is still sometimes used by some people. Deprecated meaning that it's not supported for updates and it's not recommended to use. So it shouldn't be too much of a problem. And we're going to be using a stack interface, not a stack class. So we'll say public interface stack. And let's use generics today. We'll use the type E. And you can see that we have push E, and I just used the variable E, and it's a void method. So we'll say public. Oh, you know what? Well, let's write it. Public void push EE. Now, instead of writing a method body, we're going to leave this method abstract by just putting a semicolon and say public abstract void push. So that's how we make an abstract method, and an interface is abstract. It means that there's absolutely no method body in the interface. It is in the method. It's just the method signature, as we call it. Well, it turns out that an interface doesn't do any good unless the stuff is public, because an interface is how you interface with the public. So we really actually don't have to use the word public there. We can, but it's understood. And then now, it doesn't make a lot of sense for us to use the word abstract here, since methods in an interface are, in general, abstract. That's the fallback. That's what you're making an interface for. So you actually don't have to use the word abstract with making an interface either. You just say the return type and then the method signature. And then we can do E pop, which returns the top of the stack, and we can do E peek, which just simply looks at the top of the stack but doesn't actually remove it. And that's it. That's our interface: push, pop, and peek. And we could add some nice Java comments. This interface contains methods for implementing. I'll go down a new line for implementing a stack. All right, and what is this method supposed to do? So, when you write an interface, one of the things that's pretty important is the Java docs are actually really important, because that's the rules you're expecting people to adhere by. We all agree this is what it's going to do. So this is going to be pushes a new element on this stack. And this has a parameter, so I'll say at param E, the new element. Okay, and then our next method, we would say pops, or we'll say removes and returns the element at the top of this stack. And we have an at return this time, the top of the stack. And one lower method, we'll do some nice Java commenting here. So peek just simply returns the element at the top of the stack. All right, so there are some things that could happen here. What if you said pop and there was nothing there? So let's say at throws no such element exception if stack is empty. And same with peek. Oh, we need to say at return the top of the stack. And it throws a no such element exception if the stack is empty. All right, so that's pretty much it. So basically now what I want you to do is to create this by creating a doubly linked list that uses generics and can complete this list. Also, in order to work with the program I want to use this with, we need to have an isEmpty method so that if we're going to throw exceptions if they try and pop or peek from an empty stack. So let's make a method that tells them that. And that'd be really easy to do. You just need to see if whatever your top of your stack is null. So we'll go ahead and do boolean isEmpty. We could have a size method as well, but let's go ahead and do that. And we'll just simply returns true if this stack is empty. So that is nice to know. At boolean at return true if stack is empty. So let's go ahead and get that started. But before we go any further than that, I do want to take a moment to just practice. Let's say we had a stack called. Let's say we had a stack called S. All right. Stack S. You know, what would happen if I said s.push, let's just say it was a stack of integers 7, s.push 9, s.push 14, and then let's say I did a system.out.print s.peek. What would that be? What would s.peek return? Well, since the stack was 7, then 9, then 14, peek is going to return 14. That's the last thing that was put on it. That's supposed to be a comment. 14. And I could do s.pop, and then my stack would have just 7 and 9. And then I can print what I pop. I can do, but let's peek again. S.peek. And what would that return? That would return a 9. So just want to make sure that we've gone over what it is that we pop, how we're popping and peeking, and what exactly that's supposed to look like. All right, so that being said, let's get right to making a stack. We'll make a new class. Can I do that? Can I just say new? Move tab to new window. No, I don't want to do that. So I'll make a new class called, how about linked stack? And linked stack is going to implement stack. So link stack is going to have to take in a generic if I'm going to implement this generic. And if I want to make a link stack of just integers, then I could simply, if I wanted to do just integers, I could simply say link stack and say implement stack integer, and then or just a link stack of strings. But let's try and keep the generics today. Implements. All right, well, we got 3 methods we got to do. We got to be able to push, we got to be able to pop, we got to be able to peek, right? So what I want you to do is think about what kind of linked list do I need? You know, I need something that allows me to quickly remove from where? Well, you could say from the back. if I'm adding to the front every time, I keep adding to the back of it, and then I want to remove from the back of it. We could do that. We could make like a doubly linked list so that when you're adding nodes, a node, 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 like this, and every time I add a new one to the back, and then I could just simply pop that off from the back. That certainly makes a lot of logical sense, but we don't have to do that, because instead, why don't we just use a singly linked list, okay, if this is all we're going to do, and we'll just keep adding to the front of our singly linked list. And so this here is actually the bottom of our stack, and we're adding to the front, which we're really calling which we really want to think about is adding to the top. And the linked list is perfectly situated to give us O1 access at the front, which is all we need. So we really only need a singly linked list. So what I'd like you to do is I would like you to complete the linked stack class to make a stack. You can go ahead and make it a doubly linked list if you want, but you don't have to.